26 September 1905, a paper is published by a patent clerk named Albert Einstein. This is the theory of special relativity, which states that time is not a constant and therefore it is possible to make it faster or slow it down by changing your frame of reference. But there was a problem. This was so revolutionary that it challenged long-standing Newtonian laws which were being used for hundreds of years. It took Einstein further 10 years to complete and 2 years to prove it to the world that Newtonian laws were nothing but a really good estimation. Now this new theory of general relativity opened the door to speculation that how do we harness these laws to control and travel across time. Now year is 1940. Bruno Rossi, a scientist who is obsessed with cosmic rays, discovers something weird. These rays of energy traveling great distances close to the speed of light collide with Earth's atmosphere and burst into smaller particles including muons, which are detectable on the surface of Earth. Rossi calculates that according to the half-life of muons, only 0.1% of them should be reaching the Earth. So where was all this extra energy coming from? No calculation made sense until he made use of Einstein's theory of relativity, and the results became completely accurate. It proved that these rays have actually traveled into the future, and for them only a tiny fraction of time has passed as compared to us. Hence they did not have enough time to decay and reached Earth almost perfectly preserved. Einstein's theory explains this by telling us that every matter in existence has a fixed budget of space and time equal to the speed of light, which we are continuously spending no matter what, but we can't control how we spend it. If we use it to cover more space, less of it would be left to spend on time. So more speed we have, more space we cover, and even less budget is left to spend on time. Hence it slows down for us relative to others moving at slower speed. So if you take a year-long cruise in space at 99.99% speed of light, you would return to Earth where 70 years have passed. This is called relativistic time dilation. Reaching this speed is not only realistically difficult but also requires unbelievable amount of energy, as much as everyone on Earth currently uses in 3 months. Understandably, we are very far from pulling that off. That is why I have placed it third on the list. But there is an easier way to achieve time dilation without traveling insanely fast. This theory tells us that space and time are interconnected, forming a mesh, so it is not possible to change one without disrupting the other. Objects are able to bend this fabric of space-time, and we name this stretch as gravity. More mass an object has, more gravity it produces, therefore stretching this fabric even further. Now imagine two pair of points, one near the Earth and other near a high gravity object. On Earth, it takes 1 minute to reach from point A to point B, but at a place where space-time is more stretched, everything would slow down significantly, as it would take more effort in terms of space to reach the same point in space-time. This time change is only noticeable when compared to places with lower gravity like Earth. Same phenomena is shown in the movie Interstellar, where 1 hour on the planet near a black hole of massive gravity is equal to 7 years in Earth's time. Practically, we see this in all the satellites orbiting Earth. They experienced both types of time dilation, being further away from Earth's gravitational field as well as moving significantly faster than us. Therefore, all the atomic clocks on board are slightly adjusted to match the time on the surface of Earth. But if we really want significant time travel, for now we may have to shift our focus towards biology. Alpine mammoths take a break from life every year for 6 to 8 months. Their heart rate goes down to as low as 2 beats per minute and temperature just above freezing at 5 degrees Celsius. This is called hibernation. They basically slow the metabolism so much that each month their biological age increases by just 2 days. That is 7 months of aging for every 10 years. By every means, this is a completely valid form of future time travel. But the question is it possible for humans to do it at all, or somehow for significant periods of time? This concept is nothing new. Named cryogenic sleep, it is shown in numerous movies including a 2016 film Passengers, where humans are kept in a state of hibernation while traveling for hundreds of years. But apart from science fiction, on December of 2006, a person from Japan made headlines. This hiker lost his consciousness immediately after being injured and survived without food and water for 24 days. He was rescued in a state of hibernation where his body temperature was 22 degrees centigrade and heartbeat was significantly slower. Since then, NASA has been trying to develop a stasis chamber where humans can be kept in a cold environment so a state of mild hypothermia can be induced. The concept is to slow down metabolic reactions with combination of changes in both external and internal environment of the body, which is gonna slow down aging to reach the ultimate goal of time travel. So our time machines would probably be pods where we go for a very long nap. These experiments leave scientists in little doubt that if time travel into the future is possible, it is an established scientific fact. But what about heading in the other direction? Is it possible to visit the past? It's 22nd September 2011. Italian physicists make a bold statement. They seem to have observed particles called neutrinos traveling faster than the speed of light. If true, it would reshape our understanding of backwards time travel. This claim comes from OPERA experiment buried under Italy's Gran Sasso mountain, designed to detect neutrinos coming 730 kilometers through Earth from CERN in Switzerland. At the speed of light, this would take 2.4 milliseconds, yet some of the neutrinos are reaching 16 nanoseconds faster. In other words, these particles are somehow traveling faster than the speed of light. Special theory of relativity states that speed of light is an impenetrable barrier. The faster you travel, the heavier you get, and speed of light is the limit, after which an infinite amount of energy is required to move faster. While a massless particle can travel at light speed, anything with mass can hardly come close, let alone exceed the speed barrier. So within a year, this mystery was solved. Experimental equipment was faulty. But the reason why this news shook the world is because relativity only allows us to travel back in time if we go faster than the speed of light. Clearly, that for now is not possible. So how do we cheat this unbreakable speed barrier? The only answer for it, again, comes from gravity, specifically wormholes. A wormhole is produced when an extremely high gravity object, like a spinning black hole, ruptures the fabric of space-time and forms a tunnel between two faraway points in space. This tunnel would let us cheat the length of space to travel at a different point in time, way faster than the speed of light. However, there are few complications, like needing huge amount of negative energy to keep it open. So it's because of these hurdles that past time travel is hard, even theoretically. But looking at a glance, we could easily peek into our recorded past and even experience it, thanks to the advancement in technology and things left behind by our ancestors. Come along to experience how modern humans explored and expanded on Earth in a video next week.